Today's objective is to be able to solve one-step inequalities. However, before we solve inequalities, we have to first review what they look like and what they represent. This is something that you've learned in your earlier math classes, but that we haven't really looked at in quite a while. So first, inequalities can have any of these four symbols, where each of these symbols tells us something different about what we're looking at. And we're going to go into each one of these as we go through some of these examples. Unlike equations, where the equal sign tells us both sides will always be the same to each other or equal to one another, in an inequality, one side of what we're seeing can be bigger, smaller, and or equal to one another. So when we look at this example that we have here, and we want to read what it says, we have to think about the way the symbol is written. There are many different strategies that we can use to read inequalities, but a rule of thumb that we can use to help us is the following. In an inequality symbol, the pointy side of the inequality sign is always the smaller side of what we're looking at. Meanwhile, the wider side of that inequality, or the side that opens up, is always the bigger side. It always helps to label our inequalities. So if I label my inequalities, I see that the pointed side is on the side of the x, so this is the smaller side here. And I see that the wider side, or the side that opens up, is on the side of the 4, so this side here is bigger. So the way we read this is x is less than 4, because x is on the smaller side, so x has to be smaller or less than what's on the other side, which is a 4. So again, this inequality, the way we read it is x is less than 4. So this means that x represents some number that is less than or is smaller than the number 4. Here 4 is our boundary. That means x can be any number that is smaller than that boundary or smaller than 4. However, it does not include 4. It can only be smaller than that value. Unlike an equation where x represents one specific number, in an inequality, the value of x can change. So if we were to graph this on a number line, we would start at our boundary of 4, and x can be any other number that is before 4 or less than 4, hence why the arrow is pointing towards this direction. Also notice that we did not shade in that circle. That circle is not shaded in, or it's empty, because we're not including 4 as our answer. X can only be smaller than that. So again, in an equation, usually our answer is just x is equal to some specific number. But here, x can be multiple things. X could be 3, it could be 2, it could be 1, it could be 0.5. It could be a -1 or a -1.5. It could be any number, whether whole number or decimal, that is less than or smaller than the number 4. One thing that I want you to notice is that sometimes an inequality can look different than what you originally had, but still mean the exact same thing. So for example, in this, if I rewrite our original example like this, you might be thinking, well, maybe this says something different. But again, if we label our sides, the smaller pointy side is still on the x, okay, and the bigger or wider side is still on the positive 4, which means x is still smaller than the number 4. Usually when I read inequalities, I always like to start where the variable is at. So if I read this, this is still telling me x is smaller than 4. Or if you want to write it in another way where we can say the same thing, this is also saying 4 is bigger than x, which essentially means the exact same thing. We can also see inequalities using any of the other 4 symbols. So if I had something like this is telling me, again, this is the bigger side, and this is the smaller side. Now this is telling me x is greater than 5. So x can be any number that is bigger than 5. Or if I see something like this, for example, x is this is telling me x can be bigger than, but it could also be equal to 5. We keep the little line in the bottom to show that x can also be equal to whatever's on the other side of x. Same thing as if you see it in the opposite direction. If I have this, for example, this is telling me x is less than or equal to 5. Because again, that little line in the bottom tells me that x can also be equal to whatever's on the other side. So now that we know a little bit about what these different symbols for inequality means, we actually have to use this information now to figure out solutions for these inequalities that have multiple terms in them. So in this example, we have x plus 3 is greater than 5. And we have to figure out the solution for this inequality, or we have to solve this inequality. Now, when we're solving inequalities, we're going to follow almost the exact same steps that we use when solving equations. We just have one minor difference that we're going to talk about in the next example. Our goal when we're solving an equation or an inequality is always to get the variable by itself. So if I want to solve for x, whether it's an equation or an inequality, I want to make sure I move everything to the opposite side of my variable using my inverse operations so that the x is left alone, or whatever letter I'm solving for is by itself. So here I have x plus 3, which is the same thing as 1x plus 3 is greater than 5. I want to get x by itself, so that means that I want to move everything that's not my x to the opposite side of this inequality. In this case, the only thing that's on the same side of my x that has to go to the opposite side is this positive 3. Remember that this inequality sign is almost the same thing as an equal sign in the sense that it separates the two parts of our inequality. So if we want to move from one side of our inequality to the other, we still have to use our inverse operations. So since I want to move this positive 3 to the other side, I'm going to subtract 3 on both sides and see what happens from there. This 1x is going to stay the same. This is going to cancel out. And 5 minus 3 is going to give me 2. And I bring down my inequality sign the same way that I would if I was bringing down an equal sign as well. Since the variable is by itself, I know that I've solved this equation. Part B is asking me to write the solution in word form, which means I have to write what this inequality is actually saying. And again, labeling our sides is always going to help us. So I see that the pointy side is now on the 2, so that's going to be the smaller side. And the wider side is on the side of my variable, so that's going to be the bigger side. So if I read this, this is actually saying x is greater than 2. Remember, the words that you want to use are either less than, greater than, less than or equal to, or greater than or equal to. So here the x is on the bigger side, which means x is greater than the number on the other side, which is 2. So x is greater than 2. Now part C is asking me to list a possible value for x. And remember that in an inequality, x can be multiple things. So here, x can be any number that is bigger than 2 or greater than 2. So if I pick a number that could be a solution, I can pick any number on my number line that I know is bigger than 2. So I'm going to choose the number 4 as a solution for x. And I'm going to check that that's true. Well, if I say the number 4, that means that if I do 1 times 4 plus 3, that has to give me something that is bigger than 5. 1 times 4 is 4, and plus 3 is 7, which means this is correct. This is a true statement. This gives me something that is true. 7 is greater than 5, which means 4 is definitely a possible solution. Just like it could be anything else bigger than 2. 5, it could be 10, 5.5, 13 and a half. It could be any number bigger than, x can be any number bigger than 2. Now let's see what happens when we do other operations in our inequality. In our other example, all we did was subtract 3, which acted the same as if we were solving an equation. So let's see, if I had 2x is greater than or equal to 10 here, and I want to get the variable by itself, again, I can only move that 2 to the opposite side by using my inverse operation. Well, this is 2 times x, so if I want to get rid of that 2, I'm going to do the opposite and divide by 2, or divorce the couple that we have here. So we get x, or 1x, is greater than or equal to 5. If we label this, this is going to be the bigger side here because it's the wider side, and this is going to be our smaller side here. So that means that x could be any number that is greater than the number positive 5. So it can be 6, 7, 7.5, 8.5, 10, any number that's bigger than 5 in our number line. But what happens if I change this positive 2 to a negative 2? Well, again, we're going to do the same thing and divorce our couple. So we're going to divide by negative 2. But one huge difference between solving equations and solving inequalities is that whenever you're solving an inequality anytime that you divide by a negative number, you have to actually flip the sign. So this inequality will become 1x, or x is smaller than or equal to negative 5. And we can check if that work is actually correct. Let's pick a number that's smaller than negative 5. I'm going to say negative 8. The more negative the number, the smaller it is. So if I plug in negative 8, I will have negative 2 times negative 8. And we're going to check if that gives us a true statement. We're going to see if this is true. Well, negative 2 times negative 8 is positive 16. And that is definitely bigger or greater than positive 10. So you'll see that any number that is smaller than negative 5 or less than or equal to negative 5, so negative 5 or anything below, will actually give you a true statement and it'll actually work. If I pick something that is actually bigger than 5, let's say we pick the number 3, for example, we would have negative 2 times 3. And again, we're checking if that's greater than or equal to 10. But that's negative 6, and negative 6 is not bigger than or equal to 10. So every time that you divide by a negative number, you must always flip your inequality sign. As long as this number down here that you're dividing by is negative, then you know you must flip this sign. This could be anything, positive, negative, it doesn't matter. But if the number you're dividing by is negative, then you must flip your sign. So here's our third example. We have negative x over 3 is greater than 5. Now the negative can either go with the x or it can go with the 3, but only one of the two things that you see there, not to both. So I'm going to put it in the bottom because it's just going to make our work easier. So I have x over negative 3 is greater than 5. Now this is the same thing as 1x divided by negative 3. This fraction bar here that represents division. So this is saying 1x divided by negative 3 is greater than 5. So if I want to get rid of that negative 3 in order to get the variable by itself, then I have to do the inverse operation of dividing by negative 3 and multiply by negative 3 instead. And if I do it to one side, I also have to do it to the other. And now, just like in division, you want to be very careful because anytime that you divide, but also anytime that you multiply by a negative number, it'll flip the sign of your inequality. So these two things are going to cancel out and you get 1x is less than negative 15. Okay, I multiply by a negative number, so my sign has to flip. If I would have multiplied by a positive number, then it wouldn't have mattered and my sign would have stayed the same. But in an inequality, it's very important to remember that anytime that you divide or you multiply by a negative number, it'll always flip the sign that you initially started working with. If you have something like 2x is greater than negative 8, just to clarify, if I divide by 2 to get my x by itself, this does not flip the sign, even though you get a negative 4 as your value, because the number that you divided by is positive. Something like this also doesn't flip your sign because, again, you're not dividing or multiplying by any negative number. The only time that you flip your sign is when you multiplied or you divide by a negative number.